Alright, so that's why we have the connection showing up right now. So if we look at the interface, we see that we're a good indication that the the interface is good, the connection is good on the point-to-point connection, is that we're seeing packets inbound and packets outbound, and we're not taking any errors. If you look at router 1, we probably see the same thing. Okay, there we have packets out, packets in, no errors. We are seeing carrier transitions. This means that the interface has transitioned, from up to down, or from down to up. So we see carrier transitions here. That's usually not good. What you can do, you can do the command clear counters, and this command will clear all the basically clear all the stats on the interface for us. So if we look at the show command again on the interface, basically cleared all those stats. We'll run that here on router 0. So again, clocking, timing, you have your DCE. Right now we have R0. Let's put a little note here so we know what side's the DCE. We'll just put R0 as the DCE, and we'll just put R1 as DTE. You can just put this so that we can simulate an actual scenario, even though both sides are DCEs according to the output of the show controller command. Now we can go in here and just set up the clocking, just like we're going to simulate the actual connection. Even though it's up right now, we don't have to do this, but again, just for practice, to get you used to configuring an actual physical, the physical routers, you go into interface serial 0, and you use the command clock rate, and this provides timing on the interface. So you can see here there's preset values. We'll just use a clock rate, and this is in bits. So we're going to put in here 128,000 bits, which is 128 kilobits per second. Now, to verify your clocking on interface, you can just do a show run and take a look at the interface. We're here at serial 00. We can see that we have set the clock rate manually to 128 kilobits per second. Now if we look at the interface again, you can see that a lot of people will miscorrectly use the bandwidth command. They think the bandwidth command specifies the actual speed of the interface, and that is the actual physical, line speed, and that is not the case. The bandwidth command is used not for the line speed or the timing on the interface. The bandwidth command is used for more complex scenarios that you'll see when you're using your routing protocols. The bandwidth command is used. Some of the routing protocols use the bandwidth command as one of the metrics for your your routers to select the best path through the network. Because if you have a bandwidth, say of in this case, this is a a T1, 1.5 megabits per second, and this is going to say the same router as another interface on my router here, which has a bandwidth command set up to 128 kilobits per second. Naturally, your router is going to select, if your routing protocol is using the bandwidth to calculate metric, it's going to use the faster link. So it's going to go across your T1 rather than your fractional 128 kilobit connection. So anyway, don't get those confused. A lot of people do. I guess we'll go ahead and move on from here. So So we have bandwidth, we've gone over clock rate. Let's go ahead and now what we're going to do is we're just going to configure an IP address on the interface. And you do that by going into interface configuration mode again, and use the IP address command. We're on router 0, so we want to put in up here again, we put the .1 in, so we're going to use the .1, and in hexadecimal the subnet mask is 252. Now let's set up router 1. Again, you have to write out the subnet mask in hexadecimal. It's not going to take it, and in a /30 form, you can't do that. But if you do, now if I do a show interface serial 00, you'll see that it shows me the subnet mask in a /30 notation. Same with the other side. We'll show interface serial 00 on router 1. Okay, so router 1 is the .2, which is what I have set up, and then router 0 is the .1. Again, now this is layer 3. So we went through layer 1, the physical layer, and we went through layer 2, data link layer, it was line protocol, and now we are at layer 3 configuring the IP addresses. Let's see if we have reachability between the nodes via layer 3. We can test reachability via layer 3 by using the ping command. So to do that, what we want to do first is, let's just clear our counters again. I'll show you how you can so we only have one packet, roughly one packet on each side. Okay, now let's just do a pinging from router 0. We'll see if we can ping router 1. So we want to type in the IP address of the far side, which is .2, and you can see that we have a success rate of 100%. All the pings went through. Let's try to ping from router 1 to router 0. 192.168.1.1, and it looks like we're good to go on both sides. So we know we have reachability via layer 3 now. See, we can see the packets incrementing. Now if you wanted to tell that your pings are going through, what you can do is you can just do a extended ping. Target IP, I'm just going to put in the other side again, 1.2. Repeat count here, I'm just going to put 500 to show you that we can do the show interface command and we can see those packets incrementing. You can notably see that. See over here, we do it. We got 380. Now we have 520, so we can see those packets going through in real time, going through and it looks like we're good. We have a good, successful setup here. We've established layer 1 through 3 inside of GNS3.